All right, functional groups. This is a biggie. If there's probably one thing that you guys should take away, I know everyone pretty much in here is nursing majors, but if there's one thing you should take away from this class, other than understanding the structures of organic molecules, is functional groups. This is you're going to see this probably in much more of your classes. And I think it's kind of important just to know as a nurse. If you have a patient and you're trying to, I don't know, and they're exposed to like some sort of organic molecule, and they say, well, I think, and they name it and you look it up and then there was a carboxylic acid functional group to it, you would kind of know, oh, that's an acidic group, obviously, because of the name, but you might know other properties about it. Okay, so I think this is kind of probably one of the most important things that should be remembered after this course. Okay, so what is a functional group? A functional group is what gives a molecule its characteristic properties. Okay, that's why at the beginning of the videos I said we're going to learn how to look at a molecule, and just by looking at it, you can tell me a lot about its properties. Okay, let me give you a perfect example. Let's take ethanol. We've talked a lot about ethanol, that is drinking alcohol. And I'm going to take acetic acid. This is the structure of acetic acid. Okay, acetic acid is also known as vinegar, or actually vinegar is actually a mixture of acetic acid and water, but basically it's vinegar. Okay, now look at these structures. Don't these structures look pretty similar? I mean, you got a CH3 and a CH3. You have an OH, you have an OH. Here I have a CH2, but here I have a C with a double bond O. So is that really that big of a difference? Well, I wouldn't be talking about it if it wasn't, right? So these are two different functional groups. This is the alcohol functional group. This is a carboxylic acid functional group. These are totally different. This, I drink a beer on a Friday, no problem. I would rather have ethanol in my beer than putting vinegar in my beer. Imagine if your beer was made with vinegar. That would taste nasty, all right? And let's say with that beer I had a salad. Do you think I would want to put ethanol on my salad as my dressing? Or maybe a little bit of oil and vinegar would go good on my salad dressing? Yeah, I think vinegar would go pretty well on my salad dressing. I'm sorry, on my salad. Okay, so you can tell they're very similar in structures, but their properties are way different. The way they taste, the way they interact in our bodies, everything about them is like different. But notice the structures are very similar. Well, they're not though, because once we start realizing this is a carboxylic acid functional group, this is an alcohol functional group, these are way different. They have their own characteristic properties. And that's kind of what we're going to be trying to do after this section, is to look at molecules and try to figure out what kind of properties does that molecule have. Okay, so the functional groups contain heteroatoms, like the example I gave here. Remember, heteroatoms are atoms other than carbon and hydrogen. They also can have multiple bonds, or they can have both. So for example, this had both. This has a multiple bond, a double bond, plus heteroatoms of oxygen. Okay, so you usually have a backbone, a skeletal backbone. In this case, our backbone is, a CH3 or a CH2, CH3, and then you have a group attached to it. Okay, a carbon backbone is an R group. This is kind of a shorthand. So rather than drawing it as a CH3, CH2OH, you just draw it as ROH. That's implying an alcohol, or R C-double-bond-OH. Okay, this is an alcohol functional group. This is a carboxylic acid functional group. So R could be anything. Could be one carbon, could be two carbons, could be 50,000 carbons. All right, it could be 5 carbons that have all these branching groups off of them. Okay, R is just kind of a generic way of talking about carbons and hydrogens. R is equivalent to X in algebra. All right, if that helps. I said that once to a class, and like 3 students like, oh, that's what R is. X is everything, like X squared. Well, X could be 2, it could be 7, it could be 1,000, it doesn't matter, it's some number. Well, R is equivalent to X in organic chemistry. It's anything that's carbons and hydrogens. All right, so there you go. Once again, I am predicting what my slides say. All right, hydrocarbons are compounds that contain only carbons and hydrogens. So these are the major groups. Okay. Alkanes actually don't have a functional group. An alkane is a molecule where all you have is single carbon-carbon bonds. Everything are single bonds with the maximum number of hydrogens on it. That is what's called an alkane. That is considered no functional group. Alkanes do not have a functional group. Alkenes is a double bond. It's some sort of molecule. Here, let's do a skeletal structure with a double bond in there. Look at that, kind of incorporated chapter 11.4 and 11.5 together. I love doing stuff like that. All right, so this would be an alkane. I'm sorry, an alkene. Alkane would just be like this. I can have a branching group there, you know, something like that, just to kind of give you an idea of branching groups that we'll see. You notice I have a chain and then things are hanging off of it. All right, this would be a double bond, and notice, look at my geometries, guys. I did that without even realizing it. Notice my geometry here. All right, what is it? It's trigonal planar, 120 degrees. Okay, alkynes, remember, is linear. So alkyne, I like to draw on the carbon because sometimes it can be pretty confusing. That's an alkyne. Okay, this is my functional group. None of this is a functional group because that's technically alkanes attached onto my alkyne. But this molecule is called an alkyne. It's not called an alkane. I should have not have said that. Forget what I just said. That's an alkyne. Single bonds, alkanes. Double bonds, alkenes. All right, kind of how I remembered it is an alkene, kind of, don't worry about it. And then alkyne is a triple bond. Okay, oh, and then you have aromatic. Aromatic is a special type of hydrocarbon. So all these are hydrocarbons, all right, because they are just carbons and hydrogens, no other atoms. Aromatic is a benzene ring. This is a benzene ring. We talked about it on the first, when we talked about capsaicin, I believe. That's an aromatic ring. All right, well, what does this mean? Remember, every junction has a carbon. So carbon, 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 carbon with its maximum number of hydrogens. Remember, carbon has to have 4 bonds. So this carbon right here has a double bond here for 2, and then a bond here for 3, and then 1 hydrogen. So that is a benzene ring. You can also draw the double bonds at the other places. Okay, it's what's called resonance. You might have seen, again, in other books, biology book, you might have a circle in the middle. That's the same thing as this. All right, we'll talk more about that when we get to the benzene parts of the book. Okay, so here's a summary. All right, alkanes, here's an example. That's called ethane. It's 2 carbons. We'll learn about how to name these. Alkenes, double bonds, alkynes, triple bonds, and aromatics. These are the hydrocarbon family. That's called the hydrocarbon family. These are the functional groups. All right. All right. By the way, guys, you need to memorize this. Everything I'm showing you, you have to memorize. Okay. You might say by when? As soon as you are done watching this video, you need to have it memorized. That's how soon. Okay. Okay. Next one is ones with heteroatoms with single bonds, because we are going to see families of compounds that have heteroatoms with double bonds. These are with single bonds. So alkyl halide. Alkyl means carbon hydrogen group, basically an R group. Okay, so and any halogen attached to it, fluorine, chlorine, bromine, iodine. Start getting used to this word halide, halogen. If you are still like, what was a halogen? You need to get that memorized by 6 slides ago. Okay, so that means you have to have it memorized by now. I'm going to use that word halogen a lot. All right, alcohols are ROHs. Okay, again, R is just a bunch of carbons and hydrogens. It doesn't matter how many. Ethers, okay, ROR, okay, or carbon, oxygen, carbon. Ether with its lone pair. Here's my chemistry joke of the day. What do you think this is called? This is called an ether bunny. I know you are laughing on the other side of the video right now. So, isn't that great? That's the best these jokes get. So I am sorry, but that's how it is. You have to laugh at my jokes, by the way, guys. Okay, ether bunny. All right, ether. Ether is ROR. It's like an alcohol, but instead, in place of one of the hydrogens, you have another carbon group there, another R group. Amines. Amines, huge class of compounds, especially in biochemistry. All right, amino acids. All right, amino acids have amine groups and carboxylic acid groups, which I've kind of showed you, but we'll talk about that on the next slide. All right, amines basically is a nitrogen, okay, where one of these bonds has to be a carbon. The other two could be hydrogens, or it could be a carbon and a hydrogen, or you can have three carbons. They kind of show you that. Two R groups in the hydrogen or three R groups. But at least one of them has to be, because otherwise you would have NH3. And NH3 is called ammonia. Okay, that is not an amine. Thiols. Finally, thiols have sulfur in it. It's kind of like an amine, but with, or an alcohol. Sorry, it's more like an alcohol, but with the sulfur. These stink. These smell like rotten eggs. Rotten egg smell are thiols. Skunk. The skunk smell. This is the structure of this. Is there one more? Let me think. 1 second. Yeah, that is the structure of the skunk smell. All right. So, FYI. Stinky stuff. Oh, also in natural gas. So natural gas like methane, ethane, propane, um, those those gases actually do not have any odor. They have no smell whatsoever. So you might be saying, well, when I have the gas on, if I have a gas leak, it has that smell to it, kind of like a rotten eggy smell. Well, the gas company puts in dimethyl sulfide into the gas, very small, like less than 1% of this. Okay, very, very small amount of this is in our natural gas, so that when it burns and it comes out, you can kind of smell it. Or I'm sorry, it doesn't burn. Well, when it comes out, you can smell it. When it burns, it goes like into SO2 and carbon dioxide. That really has no smell to it. All right, but this is a very, very strong smell. So our gas company puts these types of compounds in there. Okay, these are now some examples of these. So here's diethyl ether. This is used as a solvent. I also believe it was used as a anesthetic back hundreds of years, 100 years ago. They don't use it anymore. THC. Hey, we live in Colorado. Why not have a structure of THC in our slides? Here is THC. Notice they kind of do that shorthand. So it's actually 4 carbons here. So there's actually a very long, I hate when that happens. Sorry, guys. This happens quite a bit. This is actually 1, 2, 3, 4, 5. You actually have this long or hydrocarbon, like tail, outside of it. All right, but you can see in ether, you can also see what is this? What was this functional group called? Aromatic. That's a benzene ring, but this is an aromatic functional group. What does that look like to you? An alkene. Notice you can have more than one group, and then this is an alcohol. So we've got an alcohol, an aromatic, an ether, and an alkene all in the same molecule. All right. All right, now functional groups that have double bonds, or what's called a carbonyl group. A carbonyl group is this, a C double bond O. That is a carbonyl group. This is not a functional group. This is not a functional group. It's part of our functional groups. Okay, we're going to talk about aldehydes and ketones, carboxylic acids, esters, amides. They all have carbonyls in them. This is like a steering wheel. When I drive a car and someone says, what kind of car do you drive? Do you tell them I drive a steering wheel? No. A steering wheel is part of the car, just as carbonyl is part of your functional group. Okay, so carbonyl is not a functional group. It's part of functional groups. All right, and here are the functional groups. There are 5 of them. There is an aldehyde. An aldehyde is a carbonyl with a hydrogen. Okay, and obviously you always have an R group. A ketone is where you have 2 R groups and a carbonyl. Carboxylic acid is a carbonyl with an OH. An ester is a carbonyl with an OR group rather than an OH. And then an amide, which, you know, amino acids or make amides, or like a polypeptide bond, or proteins, or a bunch of amide bonds, are polyamides. It's a carbonyl with a nitrogen. Okay, notice they all have carbonyls in them, but that's not the functional group. The functional group is the carbonyl plus the other thing attached to it, an H, an R, an OH, an OR, an NH. Okay, or an NR2 or an NHR. All right, so the best way to know these is to make flashcards. So I would make a flashcard. On one side, I would put the structure of an aldehyde, and then on the back, have the name aldehyde. All right, functional groups. Um, oh, here's kind of a condensed way of drawing this. Um, you kind of have to know this. You might see, so notice I have an aldehyde, and a condensed way is CHO rather than COH. If you draw COH, that implies an alcohol. But if the H is in front of the oxygen, it's called an aldehyde. It's an aldehyde group. Okay, that's just kind of a shorthand. Um, Carboxylic acid sometimes are CO2H. They look like this, or COOH. I don't know. Yeah, so here we go. We have it. I didn't know if they had a slide. So these are condensed forms of these functional groups. Here's an ester, COO. Do you have to memorize this? Well, you know, I already have you memorizing quite a bit already. There is a lot of stuff you kind of have to know. This is something that we probably won't see too often, but I just want to make you aware of this stuff, okay? So that, you know, if you do see it, be like, you know what, I do remember seeing that. That's all I'm trying to get on something like this. Here's, I like these slides. That's kind of why I like this book. They kind of take these organic molecules and they kind of show you everyday structures for them, so that we can see that these are real things. Benzaldehyde is an aromatic ring, all right, and you have an aldehyde group. Okay, remember that's CHO's shorthand. This smells like almonds. I don't know why they're in cherries. I guess there's a little bit of almond flavor in cherries. I did not realize that. But benzaldehyde has an almond smell. Um, Maybe in class I can grab a bottle of the benzaldehyde and you can smell it. It smells more like what's that dough called, like marzipan? I don't know if you know what marzipan is. It's used in in candies. It's kind of like that candy that has like that almondy taste, but it's like an overwhelming almond taste. I hate it. My wife loves it. I absolutely hate it. But it has there are people that just love it. It has a real overwhelming almond taste to it, and that's kind of what benzaldehyde smells like. Isoamyl acetate. We are actually going to be doing a lab this semester where we synthesize this, guys. We are going to be synthesizing the odor of banana oil. Some of you are probably like, oh yes. Others are probably like, oh, disgusting. All right, it smells like runts. You guys know those candies, like the runts candy. It's a hard candy, you know, and they have all different shapes of fruits. And one of them is the banana. It has that artificial banana taste. Well, it's because it's this molecule inside of it. Or Laffy Taffy, the banana Laffy Taffy has kind of the same like taste to it. Citric acid, all right, it's a tricarboxylic acid with an OH. Very, very sour. Acids in our tongues are sour. They adhere to the sour receptors in our tongue. Very, very sour. And finally, the odor of the pineapple. Here's the structure of the odor of the pineapple. All right. So that is it. I will see you for 11.6 on the next